Good morning, everybody. Welcome to exciting Tuesday morning of Chem 1105 with your host, me, Dr. White. And as keeping with my policy, today we'll do the lab, then I'll be doing chapter 4 problem set, and then we'll get back to the moles. So let's get going. Nope, that's not what I want. That's what I want. All right, today's lab is exploring density. And one of the things I want to show you, all right, let's try this again. All right, if you look on your screen right now, you'll see the assignment exploring density. And if you notice, I got a lot there. Now, one of the important things is you'll need to graph either by hand, or I'd highly recommend using Microsoft Word, Excel. All of you as students should be able to download free through COD, Microsoft Office, or the student version of that. Now, what I've done last semester in Chem 1212, we did the same lab. I did a good job talking about it. And if you watch this video, here's a link for the YouTube video. Starting at 24:25, you can see how to do graphing. I'll go over it today, but not as in depth. Also, if you want this video, if you start, I think at 4 minutes and 51 seconds, you can see the whole lab again, me doing it back last semester when I did it. And let's get to it. Hi, density. Now, density is a measurement, and it will, you'll be exploring density of solids and solutions. Now, density is mass per unit volume. You take the weight of something divided by the volume, you'll get a number, density. And if you use cubic centimeters, meaning centimeters to measure units to get the volume, you'll get the density. And cubic centimeters is also equal to milliliters. One cubic centimeter is 1 milliliter. All right, so you'll be doing a graph for the solutions, and I'll talk about that in a second. Now, the equipment you'll need are the cylinders they picture here, your graduated cylinder, your balance. Last lab I showed you how to do that. You'll need a pipette, you'll need a spoon, you'll need a weigh boat, plastic cups, you'll need a wax pencil they give you, and a ruler. I couldn't find my ruler. And by the way, hang on 1 second, I've got to get something real quick. I'm back. Now, here's a weigh boat. Now, to find, I got my little container of stuffed goodies. To find this, which are your three cylinders, it's probably in this green black bag that says small items enclosed, and these are small items. Now, for this lab, you're going to have to make up a number of solutions. And you'll do that in these plastic cups, which you can mark with your grease pencil. Obviously, 0% is a straight 50 grams of water. For 10%, you'll weigh out 5.5 grams of sucrose. Sucrose is sugar. Now, how do you weigh out stuff? You can use a weigh boat. And I just want to check something. And they're all right. But I was just checking, they don't do it. I don't know if you can get 75 grams of sugar in a weigh boat, but for the smaller amounts, what you do, you take your balance, turn it on, it helps, but I won't. You zero it, which is the button tear. You put this on, you tear it, put your 5 grams of sugar in. Now, you'll have your 50 milliliters of water, which you use this to measure up to here. And you'll put the water in here, you'll have the sugar in here. And here's the fun part about weigh boats. They're designed, you grab the corners, you're going to have solid in here, and then you pull up. See how it pulls up? And then you can dump the sugar into the water in the beak. Now, I find the spoon, they give you a plastic spoon, stir it till it all dissolves. Now, a couple things. One, they tell you use deionized water, or what was it? Purified water. Nah, you can use regular tap water for this lab. Don't tell anybody, but you can. Now, a couple things you have to have. You have to have your own can of pop. And notice they say if a carbonated beverage is used in activity 4, you have to open it and let it degas for about 24 hours. So take a can of pop, pop the lid, put it somewhere safe, come back 24 hours later. Now, one of the things last semester, students said, where do I get sugar? Well, the cheapest place, and I don't get any kickbacks, to get sugar is Walmart. And if you notice, their brand, 4 pounds, is $2.94, which is probably one of the cheapest prices around you can get sugar now. Now, you can buy smaller quantities, but you're going to pay a lot more money. You already have sugar in the house, that's fine. But if you need sugar, cheapest place is Walmart. Now, you have to make these solutions, and you'll make them in your cups that are labeled 0, which is pure water, 10, 20, 30, 40, 50, 60%. Notice here, for the higher level percent, you may have to put it into microwave do only about 10 seconds, take it out, stir it, and the cup might be hot, so be careful. But you shouldn't get this till you see bubbles in there that's boiling. Nope, nope, not that hot. Now, for each one, like 10, you'd have in your cup 50 milliliters of water. You'd weigh out 5.5 grams of the sugar and you put it in. Now, your balance goes to two significant figures past the decimal. If you're trying to get 5.5 grams, don't spend 20 minutes trying to get 5.50 grams. If you're at 5.51, 5.52, that's okay. If you're at 4.98, that's okay. Put it there, or not 5.9, 5 point, say 4.5 or 4.9, that's okay. You can always take a little out or put a little in. So you'll need to make these solutions. You'll need the pop. Now, the first activity will be with your ruler. You'll measure each one of these solids. The distance across is the diameter. The height is the height. Profound. Now, you'll need the radius. And the radius you'll calculate by the diameter divided by 2. Now, to calculate the volume, is pi, which is 3.14 times r squared, the radius squared, times height. And here they give you pi, I think it was today or yesterday, pi day. I saw somewhere on the internet, someone had pi to like 30 significant figures. We don't use that. But anyways, this will give you the volume. You'll also use your balance tare and weigh each one. So here you'll do the mass, you'll weigh it, the height, you'll measure it, the diameter, you'll measure, the radius you calculate, and the radius is 1/2 of the diameter. So to get radius, take the diameter divided by 2. The volume, you'll take pi 3.14 times r squared, and you can do that on your calculator or just r times r, then times the height. That will give you the volume. And the density is the mass divided by the calculated volume, and you'll get a density. And you'll put this in. Now, important thing about density. Let me make some room here. Oh, I should remind you, for every lab, you should wear your safety goggles and wear gloves. And today's lab, everything, when you're done, the solutions can dump down the sink. Obviously, the little cylinders safe. All right, let's talk a little about density. Density is mass per volume, and generally that's grams per milliliters. There can be other units, but in chemistry, we use grams per milliliter. Now, important thing about density. lower density objects float in higher density liquids. And higher density objects sink in lower density liquids. Again, lower density objects float in higher density liquids. Higher density objects sink in lower density liquids. And this is, let's talk about it. Now, if you look on your screen, hopefully let me make sure you can see it. Density of cork is 0.35 grams per milliliter, which means it's much less than 1. Water has a density of 1.0 grams per milliliter, 0.0 grams per milliliter. And if you see on your screen, the life preserver, which is made of cork surrounded by, I don't know if it's plastic or whatever that material is. And those are used, if somebody's drowning, you throw it to them. How does that work? It keeps them afloat because the cork is a lower density in that ring than water, and that allows it to stay on the surface and help a person not sink in the water, drown. Now, let's do another density. Iron has a density of 7.874 grams per cubic centimeter or milliliter. And if you had an iron cannonball and a big barrel of water, water has a density of 1.0. Since the iron density of the cannonball is higher than the water, you put it in there, what happens? Bloop. I don't know if it goes bloop, but it sinks right to the bottom. In case you've never seen one. Here's an iron cannonball. If you drop one of the, well, you can buy them. Oh, it's a shot put. But if you take an iron cannonball and you drop it in a bucket or barrel of water, because they're made of, well, these are steel, but let's just say iron, it's going to drop right there. And that all goes back to lower density objects float in higher density liquids, higher density objects sink in lower density liquids. By the way, I think a feather is 0.01 or 0.001 grams per milliliter. You take a feather and put it on a bucket of water, it floats on the top. So in part 1, you will be, wrong thing. you'll find out the density of these different cylinders and you'll calculate it. And in the lab, I'll talk about it later on. Now, in part 2 or activity 2, you'll determine the density of solutions. And as they say, you'll put 0%, 5 milliliters of water in a 50 milliliter graduated cylinder. And what you'll do before you put anything in the cylinder, when it's dry, you'll take your balance, tear it, put this on there, and to measure the weight and record it. Next, you'll put 5 milliliters in here and weigh it and record it. And then record the mass, add more water until it's up to 10 milliliters, and you'll weigh it again. And then you'll do that at 15, 20, and 25 milliliters. And from that, calculate the mass of the solution, and the mass of that water, which is not really a solution, is the weight of the graduated cylinder and the water minus the weight of the empty graduated cylinder. And then you'll graph it. Now, I'm going to show you how to graph in a little while. Now, for this activity, you'll repeat the steps for each of the 6 sucrose solutions. In other words, you've made in a cup 10% sucrose, sugar and water, which we did earlier at the beginning. I showed you what you have to make. In your empty graduated cylinder, you'll put in 5 milliliters of the sucrose, weigh it. Then you'll add on up to go to 10. Then you'll add 20 milliliters of the solution, then 25. Where it says water, you'll, for the next parts, do 10% of the sucrose and that. And you'll plot all those on a graph. I'll show you how. Now, here's the data you have to fill in. The mass of the cylinder should be the same all the way down. In the water, that's 0%. You'll put 5 milliliters, weigh it with the graduated cylinder, 10, 20, 10, 15, 20, 25. Down the sink, you'll take your 10% sucrose, put in 5, 10, 5, weigh it, 10, 15, 20, and 25. Now, for each one of these, the mass of the solution is this column minus the mass of the cylinder. The mass of the solution is this column minus this. And you'll do this for all of them. Now, to determine the density, you'll need to graph it. And be sure to put the y-intercept. In fact, I've put in the assignment area a graph. Let's see if I can pull it up. Right here. And here I show you how in Excel to make a chart. Step by step, make a chart. 1, fill in this volume and the weight of solution. And you'll do this for water, the 10, 20, 30, 40, 50, and 60%. Once you get the hang of it, it's not hard. Highlight the area with the names, click Insert, and click Recommended Chart. Now, up here, see where it says Insert, you would highlight this, and then click here, Recommended, and click on the line. When you do Recommended, the one with the dots, this one. Then click on the line and you'll fill out the trend lines. And format trend lines. And let me move this. And you'll want to set the intercept over here to 0 and click on display equation. When you do that, get rid of this, move me over, you'll see this formula. Y equals 1.1807x. And notice here, I have on the Y, the volume first, that's this here, and on the y-axis, the weighted solutions. And this slope, the number 1.1807, is the density of the solution. I just made up some numbers to make up a graph. Now, you can watch me do this in real time if you go to the lab assignment area, and you'll see how to do the graph starting at 24 minutes, 25 seconds of this video. If you want, you can watch me probably do a better job. For today, I'm a little off my game, I'm sorry, but I didn't have a good night's sleep. Fact of life. But anyways, you can see the whole lab again, see how much different I do it. All right, so what you're going to be doing is finding the equation y equals that, and that, you know, where I have y equal 1.1807x. That's what you'd fill in here, and the density is the number in front of x. Now, here they ask you, will it sink or float? Where it says predictions, don't do that. You'll still have some of your sucrose solutions. And for each one, put this different ones, those 3 cylinders, one at a time in the plastic cup with this all water. Does it sink or swim, sink or float? And put down your observation. If you want to do your prediction, you can. Now, for the determination of sugar in your pop, what you'll do is make a 5% solution, 10%, 15, 20, and 25. And what you'll do is mass of the cylinder, mass of the cylinder, and you'll do the same sort of thing. Let's go way back here. Where for a 10%, you'll put in 5.5 grams now of the pop plus 50 grams of water, and so on. I have to check that to make sure I'm doing that right, but yep, I was right. Right here to make those solutions, use this table up here to make your different pop solutions they want you to make right here. Instead of sucrose, right here, you'll use the pop and you'll weigh it out. And what you'll do is get for the 5, 10, 15, 20, and 25, the weight of the mass of the cylinder will still be the same. You measured earlier, you'll measure the 5% solution. I'll put 5 milliliters in here. The 10%, you'll put 10, and then so on. And then you'll get the weight. And you'll graph it just like I showed you. And the density is the slope. And then you can look at the graph you have from the different, here, let's see, they have it, the different densities, and which one of these densities from table 3 are closest to the density of the pop, and that will tell you the percent sucrose. And that's today's lab. Now, if we look at the write-up, here's the write-up, which you can download from the assignment area. And you'll fill in the data. Now, here are the accepted. What sources of error could cause the difference? And you have to answer that. Here's your data here. And then what happens to the density of solution as the concentration increases? And here you'll get, for each one of these, you'll calculate the density from table 3. And what happens to the density when this increases? And you'll see these numbers and either get smaller or larger, stays the same. And here, you don't have to do the predictions, but for each one in the cup of your sucrose solution, did it sink or swim? I'm sorry. You'll either sink or swim. No, I don't think those little cylinders will swim, but you'll see, does it sink or float? And here, for the last one, for the sugar, for this pop, you'll have the data, and then you'll answer these questions in 3. And that's today's lab. Remember, when you're, where's it's over here. When you're using your balance and you turn it on, when it's at 0, you should see the little G up here. You probably can't see it. You don't click on this button until you see the G. Remember, the tare is for 0. Plus, this is a really good balance they give you. And that's today's lab. Now, remember, with all labs, wear your safety goggles, proper equipment, safety equipment. And if you have any questions whatsoever, ask me. Now, let me just show you something once more for this lab. Sugar you can get from Walmart. Good morning, everybody. Ah, sounds familiar. Yeah. All right. I haven't shown it to you. All right. And then the last gram, you'll put it again. Watch carefully. And now here I do a better job starting from scratch. You can also here you can see how I set it up. A couple years, but Google, if you have a Google email account, Google also has a spreadsheet available to you. Oh, by the way, like I said, Google has spreadsheets if you want to use theirs. And you can come back and watch the video again. Notice right here, I put in the volume for one of my runs and what the density is. And how do you measure density? The weight divided by the volume of the material. And I'll go back and show you that again. Well, let's see how to graph this. If you notice right here, I have step-by-step instructions. Make the chart, fill in the data. I've done that. Highlight it. Then you click on insert. And then see here, recommended charts. Click on that. The one with the line of dots, you click on. And I'm going to hit OK. And here's my chart. Now, here's the important thing you got to know how to do. Click on the line. And then right click. And then scroll down to add trend line. Click on that. If you move us over here, and then where it says display equation on chart, click on that. And where it says set intercept, click on that. And this number in the box should be 0.0. And if you notice right here, it says y equals 1.1807x. That's your equation. That number in front of x is the density. The slope of the line is the density. So for this liquid, whichever. And that's how you do it. And you can go back to that video. I have a link. That's the URL for that video in the density lab. Remember, the lab we did last week is due this week. Also, remember, for the density lab, take a selfie, maybe with this, go click, well, you go the button to click and take a selfie and make sure you include that in the lab. Otherwise, per chemistry department regulations, I have to give you a 0, and you don't want that. So don't forget, you only need one selfie. All right, that's today's lab. Any questions? Again, if you have any questions about a lab, come to my office hours. Don't forget, I have office hours today from 6 to 7:15, and tomorrow from 6 to 7:15 in the evening. Now, some of you might be working, and I've had that happen. If you really need help, email me, and on either Thursday or Friday, when we're both available, I'll set up a private email, Zoom meeting to help you out. I'm here to help you, and I will. All right, if I look at the clock, let's take a 5-minute break, and we'll come back in 5 minutes. That's be 10:46, and then we'll go through chapter 4, problem set. All right, I'll see you in 5. Sorry about the delay. It was a little longer. All right. One thing I should go back to the density lab. And if you have like one of your solutions, you measure, say, the 5% solution of sucrose, and I'm just making up numbers. You find out 5 milliliters weighs, I don't know, 5.75 grams. How do you get the density? Density mass divided by volume. And therefore, for this solution, if that's what you got, it would be 5.75 grams per 5, and probably we could call this 0, 0. Do it to 3 significant figures. And now I can pick up my calculator, clear it, 5.75 divided by 5.00, and I get a density of 1.15. And that's times 10 to the 0, which is 1.15. And that's the units grams per milliliter. And that would be your density for the 5% solution if its volume was 5 milliliters, and then you do 10, you can do that throughout. And I just wanted to show you that. All right, let's now do chapter. Let me close a few things so I don't need everything open. All right, on your screen, you should see chapter 4, practice problems. And as you learned from test 1, why do I call them practice problems? Well, now you know. And the question number 1 that you should know, again, this is for test number 2 that will be coming up in the near future. It's in my syllabus, the date, I don't remember it now, but draw the Lewis structure for the following elements. When you have an element, what are we talking about? Valence electrons. Oh. And if you look at your periodic table, you look at the top, the number there is valence electrons, not the atomic number, number on top. Hydrogen has 1, so you put 1 dot. Now, the rule for Lewis structures, you put 1 dot on each side before you double up. For the Lewis structures of elements, you put 1 dot on one side before you double up. So if we look at carbon, how many valence electrons? 4. So you should have, and I'm sorry, I got to open something up again. All right, what did I just do wrong? I see what I did wrong. All right. Here we have it again. Let me make sure you can see it. So carbon has 4 valence electrons. You put 1 dot on each side. You don't put 2 dots on a side until each side has a dot. Oxygen, this is one way of writing it, 1 on each side. An organic chemist put the 6th, 5th, and 6th on top like this. 2 sides have to have 2 dots. 1 side has, 2 sides have 1 dot. Now, next one is, what ion does the following element form? How do you do that? Let's do lithium. Give me a second to redo something. There, I got that fixed. Sorry about that. So the question is, what ion does lithium form? So how do we do that? You have to look at the number of electrons and protons. Lithium has 3. Then you say it wants the same number of electrons as the nearest noble gas, numerically. Helium is 2 away, 1 away at 2, and neon is 7 away at 10. Which is closer? Helium. So what does that mean? To find the ion for lithium, you have 3 electrons, 3 protons. The nearest noble gas, helium, has 2 electrons. You don't change the protons. Now, each electron has a -1 charge. Each proton has a +1 charge. Do the math. Add these together, and you get a +1. How do you show the ion? The chemical symbol and superscript right. If it's just a plus or minus, you just show plus or minus. If it's a number, you would show plus on the number or minus on the number. Let's do another one. Let's do magnesium. How do you do that? You look at the periodic table. Magnesium has atomic number 12. What's the nearest noble gas? Argon at 18, 6 away, or neon at 10, 2 away. Hopefully you think 2 is closer, 2 away, and it is. So how do we find that ion? I say magnesium. Yep. It's at 12, so it has 12 electrons, 12 protons. The nearest noble gas is neon, which has 10 electrons. This should be protons, and still has 12 protons. Do the math. 10 times minus 1, each electron has a minus 1 charge. 12 times plus 1, each proton has a plus 1. That's minus 10 plus 12. This is a plus 2. How do you show the ion? Chemical symbol, and then that's a plus 2, or the newer way, which I don't like, is 2 plus. Either one. Now, once you know an ion for any member in a column, you know them all. Now, the last one I'll do is oxygen. Oxygen has an atomic number of 8. What's the closest noble gas? And it's neon at 10. So what ion does oxygen form? Now, oxygen has an atomic number of 8, 8 electrons, 8 protons. Wants to go to the nearest noble gas, and that's neon with 10 electrons, but it will still have the 8 protons. So I'll do the math. Each electron is a minus 1 charge. Each proton is a plus 1 charge. Multiply it, you have minus 10 plus 8. You add them together and you get minus 2. So what ion will oxygen form? Chemical symbol to the right superscript minus 2, or you could write it 2 minus. I like the old way better. And that's how you do that problem. All right, next. What is the empirical formula for a molecule formed with the following ions? And remember, which means hint no, all molecules have a net zero charge. So the charges of the different ions have to add up to 0. You can't change the charge, but you can change how many. And if we look at B, calcium plus 2, chloride minus 1. And let's take a look how to do that. So this is a plus 2. This is a minus 1. Does that add up to 0? No. You can't change this, but you can change how many. How do I get to 0? I put a 2 there. And what does this mean? 1 calcium and 2 chloride ions, which you show like this. No space there. And that's how you do it. Now, let's look at the same problem and look at E. E is calcium plus 2 and bicarbonate minus 1. How do you do a polyatomic ion? And once again, you have a +2, a -1, get that from there. That has to equal 0. It doesn't. How do you get it to 0? You put a 2 there. And now it is. Well, how do you show that? This means there's 1 calcium, but there are 2 of the bicarbonate. How do you show that? Bracket, write the bicarbonate, close bracket, subscript 2. And that's where you get that number. And that's how you do it. Now, the next one is draw the Lewis structures for molecules. How do you do that? Remember, we're talking about covalent bonds initially. And a covalent bond is a sharing of pairs of electrons. And for Lewis structures, you take each atom and look at the Lewis structure for the atom element. And then you see you have unpaired electrons in one element. Let me move me over a little here. And unpaired here, you pair them together. Now let's look at ammonia. How do you draw the Lewis structure for ammonia? You look and find nitrogen has 5 valence electrons, hydrogen has 1 valence electron. The only way it will work is putting nitrogen in the center. Each hydrogen has 1 unpaired valence electron. Notice nitrogen has 1, 2, 3 unpaired electrons. And in ammonia, you have 3 hydrogens. So one hydrogen says to the ammonia, nitrogen, I have an unpaired electron, you have, let's share. And another one does the same thing. And the third hydrogen does that. You can write it this way, or remember, this is the non-bonding electrons pair or non-bonded electron. And each one of these pair of electrons is a single bond. Now let's do oxygen, O2. Oxygen has 6 valence electrons. You've learned how to look up that on the periodic table. And I have 2 of them in oxygen gas, what you're breathing now. And this oxygen looks at this one and says, I have 2 unpaired electrons, you have 2 unpaired electrons, let's share. And they do. And the non-bonding electrons or non-bonded electrons are still there. Now, let me remind you the octet rule. The octet rule says atoms share, gain, or lose electrons in order to have an octet. 8 valence electrons. The exception is hydrogen. Hydrogen's octet is 2. So if we look at ammonia, if I look at one of the hydrogens shared in its own, it has 2 valence electrons, same with the rest. Now, if I look at nitrogen, shared and non-shared pairs of electrons, I'm circling it in blue, 2, 4, 6, 8. It has an octet. Now, if we come back to oxygen, each one should have an octet. shared and non-shared pairs, 2, 4, 6, 8. And both of those options have that. And by the way, 2 pair electrons, you should know that's a double bond. Now, let's look at sodium cyanide I. How do we do that? Good question. And before we do that, let's go to our friendly neighborhood periodic table. If we look at the first 2 columns, the alkali metals, lithium, sodium, potassium. Second column, the alkaline earth metals, magnesium and calcium. Those always form ionic bonds. The alkaline earths and the alkali metals always form ionic bonds, which means they form an ion. Lithium, sodium, and potassium +1, magnesium, calcium +2. What does that mean? And the question is, draw the Lewis structure. Oops, wrong color. Three points each. And sometime in the future, you saw this, draw the Lewis structure for this molecule. So we look at valence electrons. Sodium has 1 valence electron. Carbon has 4 valence electrons. And nitrogen has 5 valence electrons. Now, sodium will always form an ion, and that's this ion. Carbon has 4 valence electrons. Nitrogen has 5 valence electrons. And if we look at the carbon, it says to nitrogen, oh, look, you have 3 single unpaired electrons. I have right here 3 single unpaired electrons. Let's share. And they do. And what that means is 1 pair, 2 pair, 3 pair. The nitrogen still has its non-bonding electrons. But if we look at carbon, 6 + 1 is 7. That's not an octet. But sodium had a valence electron. It lost it to form this cation. Where did it go? It went to the carbon. Now carbon has an extra electron, so this whole thing has a -1 charge. So between carbon and nitrogen, there's a triple bond. Between sodium and the polyatomic ion cyanide, Cn-, there's an ionic bond. And if we look at carbon, it now has an octet. If we look at nitrogen, circled in blue, the valence electrons, it has an octet. So in sodium cyanide, NaCN, you have both an ionic bond and a triple bond. All right, you should know how to name the 3 types of covalent chemical bonds. And I don't have here, but you should know how many pairs of electrons. Single bond, 1 pair. Double bond, 2 pair. Triple bond, 3 pair. And with that, we're done with the problem set. Any questions on that problem set? Hint, you should know how to do those for test 2. Hint, you should know how to do those for test 2. All right, let's continue on, but first I've got to open something. All right. Let me get back to where we should be. Now I have on this slide, remember a mole. A mole is the chemist counting unit. And we look at test number 1, test number 2, excuse me, important information. You should know how to use 1 mole of an element equals Avogadro's number. You should know 6.02 times 10 to the 23rd is Avogadro's number of atoms of that element. 1 mole of a compound equals 6.02 times 10 to the 23rd molecules of that compound. And the other stuff we'll talk about either today or tomorrow, but let's do some practice with these 2 concepts and your good buddy, your good friend, unit analysis. Now, normally I'd put sodium here, but sometimes I might put the chemical symbol. And the question is 5 points. How many moles sodium are in 8.113 times 10 to the 25th atoms of sodium? So how do you approach this? First of all, what are you being asked to find? How many moles? And for some reason, years ago, I came up, put a question mark, moles of sodium. What are you given? 8.113 times 10 to the 25th atoms sodium. This is the only number we have to start with, so I will. If I had some magic ratio, I multiply this number by what units do I want my answer to be in? Well, we took the time right here to figure out moles of sodium. Now it's time to use your good buddy, your good friend, unit analysis. How do you do that? Whatever units you're trying to get to goes on top of the ratio. Whatever units you're trying to get rid of goes underneath. So now I'll write that. And where do I get these numbers? Good question. Now, let me remind you, you have two things equal each other, A equals B, you'll always have two ratios. You can develop A over B and B over A. Well, where do I find a relationship between moles of an element and atoms of an element? Well, as I've told you in the past, I've cut down on memorization. And 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms of that. So if I look at this, 1 mole of sodium equals 6.02 times 10 to the 23rd atoms of sodium. So now I can go back and say 1 mole of an sodium is 6.02 times 10 to the 23rd atoms. Where do we get that? From the important information. One mole of an element, and this you'll be given important information, equals 6.02. So this is A equals B. And top here, 1 mole of an element, sodium. Remember, you can have A over B, and you could also have B over A. In this case, I have A over B. 1 mole per 6.02 times 10 to the 23rd. Now, before I pick up my calculator, I'm going to say, do my units cancel out? And notice I have atoms of sodium divided by atoms of sodium. And anything divided by itself becomes the number 1, cancels out. So this divided by itself is 1. I'm only left with moles of sodium. That's what I want to get. So now I can pick up my calculator, and I will. I'll turn it on, clear it. 8.113 blue double E 25 divided by 6.02 blue double E 23. And my calculator gives me this massive number. This. Well, when you multiply and divide, you get the same number of significant figures as the number with the lowest significant figures. This has all non-zero numbers, 4 significant figures. 1 is an exact number in this definition. Avogadro's number is, for this class, 3 significant figures. What's the lowest number? 3. So you have to round this off to 3 significant figures. Keep the 1, keep the 3, keep the 4. Use this to round off. It's 4 or less, or 5 or higher, and 5 or higher. Drop that, increase that by 1. And the correct answer I have O2, it's really 2. This would be your correct answer. So once again, we figured out, what are we trying to find? What are we given? And we read that. Next, whatever we're given, this is the only thing we have. We put that, we have a ratio. We put at the equal, our answer, how many units we want, which is moles. And then whatever we're trying to get to, the units go on top of that ratio. Whatever we're trying to get rid of, the units go in there. And where do we get those numbers? From this relationship. 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms of that element. Remember, if you have A equal B, you can always have two ratios. Therefore, 1 mole from here per 6.02 times 10 to the 23rd atoms of sodium. Do the math, and that's how you get the answer. Now, what I like to do is another problem. We're going to take time for each step for you to do it. Oops, wrong color. All right, we're going to do this stepwise, and I'm going to need your help. That comes from a TV program when I was a kid called Winky Dink. But anyways, I'll explain that another day. How many atoms calcium are in 7.436 moles of calcium? Right here, what I'd like you to do, question mark, what are you being asked to find? And then what are you given? Your turn. Write down or think about what are you being asked to find? What are you given? That's all I'm asking you to do. When you're done, vote yes, I'm done. All right. So what are we being asked? How many atoms calcium? What are we given? 7.436 moles calcium. And it's important to put the units. That's why it's called unit analysis. Now, there's only one thing we have to start with, this number. What units do you want your answer to be? Write that down. I just drew the line. Your turn. And when you're done, just writing the units here of your answer. Oh, yes, please. And look by the question mark up here. All right. Well, what are we trying to find? Well, we determined that. Atoms of calcium. Now, the important thing about unit analysis, to go from what you have to your answer, you multiply it by a ratio. Now, I'm going to ask you what units, not numbers, go on top and bottom of that ratio. Your turn to have some fun. All I'm asking you is what units go on top and bottom of that ratio. All right, my turn. It's time to use your good buddy, your good friend, unit analysis. And how do you use it? Whatever unit you're trying to get to goes on top of the ratio. Whatever unit you're trying to get rid of, go underneath. Therefore, I should have atoms, calcium on top, and moles, calcium underneath. Now, where do we get these numbers? Remember, 1 mole of an element equals 6.02 times 10 to the 23rd atoms of that element. 1 mole of an element equals 6.02 times 10 to the 23rd atoms of that element. In the past, you'd have to memorize that for my class. That will be in important information test number 2. Now, your turn to put in the numbers. What goes on top for atoms? What number goes underneath for moles? Hint, hint. And vote when you're done. In case you can't see it, I'll write it here. Oh, you're done. So where do we get a relationship between moles of an element and atoms? Right here. And you'll be given this. 1 mole of an atom, of an element, and I can put 1 here, equals Avogadro's number. Remember, two things equal each other. You have 2 different ratios you can form. And we're doing the second one. This would be 6.02 times 10 to the 23rd atoms. Now, before I continue, I'm going to check my units. Notice this is moles of calcium divided by moles of calcium. Anything divided by itself becomes the number 1 and cancels out. What units am I left with? Atoms of calcium, which is what I want. Now I'll pick up my calculator and do the math. And my calculator gives me this number. But on test 2, like test 1, I'll take off points if you don't do it right. Please use proper significant figures for all calculated answers. This has all non-zero numbers are significant, 4 significant figures. 1 is an exact number. Avogadro's number, 3 significant figures. And therefore, the answer you get is the same number of significant figures as the number you're multiplying and dividing that has the fewest. And what's smaller, 4 or 3? Hopefully you pick 3. Your turn to round this off to 3 significant figures. Then I'll do it. Your turn. And when you're done, please vote. All right, time for me to get to work. How do you round this off to 3 significant figures? Keep the first significant figure, keep the second, keep the third. Since we're trying to get the 3 significant figures, the next one we use to round off. 6. Is that 4 or less or 5 or higher? And hopefully you all pick 5 or higher. I'm going to drop this and everything else, and the number in front I'll increase by 1. And that's the answer. 4.48 times 10 to the 24th atoms of calcium. Now, if you're having trouble rounding off, come to my office hours or see me after class. If you're having trouble using your calculator in scientific notation, come to my office hours or see me after class. Or if you really need it, email me and we'll see if we on a Thursday or Friday, we can set up when we can meet. Because Monday, Tuesday, and Wednesday, I teach. All right. Now, let's do another one of these. I'll do this one, then I'm going to share and let you have some fun too. Question is 5 points. How many moles HCl, and that's called hydrochloric acid, we'll learn more about it later in the semester, are 8.3333 times 10 to the 35th molecules of hydrochloric acid. So what are we being asked to find? Moles of HCl. What are we given? This number of molecules, because this is a molecule, hydrochloric acid exists as a molecule of HCl. And now, how do we begin? Well, this is the only number I have to work with, so I will. That's better. And now if I had a magic ratio, not magic, it's just math, what units do I want my answer to be? Well, we figured out. What are we trying to figure out? Moles of HCl. And now I'll use my good buddy, my good friend, unit analysis. If you figured out, I like that siren whistle. And how to use your good buddy, your good friend unit analysis. Whatever we're trying to get to, the units go on top of the ratio. Whatever we're trying to get rid of, the units go underneath. And where do I get the numbers that go in there? Well, in case you forgot, important information, test number 2. 1 mole of a compound, and hydrochloric acid is a compound, equals Avogadro's number, 6.02 times 10 to the 23rd molecules of that compound. 1 mole of a compound equals 6.02 times 10 to the 23rd molecules of that compound. And I'll write it down again right here. So where do I get these numbers to go in this ratio? 1 mole of a compound, in this case HCl, equals Avogadro's number of molecules of HCl. Now, before I pick up my calculator, I'll check my units. Notice this is molecules of HCl divided by molecules. And anything divided by itself equals 1, which means it cancels out. This cancels out. I'm left with moles of HCl. And now I can happily, notice happily, clear my calculator, put in 8.3333 double E 35 divided by 6.02 blue key double E 23. And my calculator gives me, let's move down here, equal 1.38426 9, there are a couple more numbers, I'm not going to use them, times 10 to the 12th. And remember, when you multiply or divide, you get the same number of significant figures in your answer as the number with the fewest significant figures. And you learned for test 1, if you didn't, come and see me for help. All non-zero numbers are significant. 1, 2, 3, 4, 5. That's 5 significant figures. This is 3 significant figures. The 1 is an exact number, plays no role in there, which is the smallest number. Hopefully you all pick 3. Now, that means you have to, when you multiply and divide, you get the same number of significant figures in your answer as the number that has the fewest significant figures. In this case, 3. So I'm going to let you, well, I'll do it, and then the next one I'll let you. Keep the 1, keep the 3, keep the 8. Use the 4 to round off. Is that 4 or less? Yes. So I'm going to drop that, not change anything else. And my answer is 1.38 times 10 to the 12th moles of hydrochloric acid, HCl. And that's how you do it. Now, one thing I haven't mentioned, but I better mention now. On a test, if you just wrote the answer and you got it right, you're going to get your 5 points. What if you made a math error? You pressed the wrong button here and you didn't get 1.38. Say you figured out and you got 1.46 times 10 to the 11th. Well, if you didn't show your work, I'm going to give you 0. But if you show your work like this and it's correct, but your answer here is wrong, I say, oh, you did a math error. And I'll just take off 1 point, so you'll get 4 points instead of 0. So it always pays to show your work on problems like this on my test. It always pays to show your work on problems on my test. So if you make a math error, or if you copy a number down, what if for some reason, I've seen this, somebody instead of writing this down from the problem up here, they do this. I've seen people do that. I don't know where they got it. Well, when you do the math, you're not going to get the right answer because this is wrong. But if you show your work, I said, whoa, you copied the number wrong. I'll call that a math error, and I'll just take off 1 point. You just showed the answer and you had the wrong answer, you get 0. All right, let's go through this one. How many molecules? I can go a little over and we're going to end a little early today because actually we're doing quite well in the syllabus. Let me check. Hold on. Actually, we're doing really well. So let's do one more problem and then we'll call it a day. A busy day. All right. Now, let's look at this problem. How many molecules of water, H2O, are in 8.1 times 10 to the fourth moles of water? Right here, we're going to do it stepwise. What are you being asked to find? What are you given? And why don't you do that? And then vote yes when you're done. All right. What are you asked to find? How many molecules of water? Which means the units of your answer should be molecules of water. What are you given? This 8.1 times 10 to the fourth mole of water. So this is the only number we have. So I'm going to start with that. Oops. There's some magic ratio. You could multiply moles of water. What units do you want your answer to be? Your turn to figure that out. And look by the question mark. You just wrote something. All right. Where do you find out what goes there? Well, right here. You want to find how many molecules. Water. So it's time to figure out what units go on top and bottom, not numbers, what units. Use your good buddy, your good friend, unit analysis. Remember, what units go on top, not numbers, and what unit goes underneath that ratio. And when you're done, please vote. Remember the red arrows. Whoop. And whoop. Or if you can do it at the same time. Whoop. And if you want to have me do it, you can also vote yes now. Remember, I'm just asking what units go on top and bottom of that ratio, not the numbers. All right, looks like some of you are having a little difficulty, so I'll help out. It's time to use your good buddy, your good friend, unit analysis. And whatever we're trying to get to, the units go on top of the ratio. Whatever we're trying to get rid of, the units go underneath. And now I'll write those in. And that's all I've done. Trying to get the molecules of water, so I wrote it on top of the ratio. I want to get rid of moles of water. I don't want that in my units and my answer. So I go that underneath. Now, where do I get these numbers? Well, where do I find a relationship between moles of a compound and molecules of a compound? Well, in case you forgot, you go to important information, test number 2. Let me clean this up a little. And here, 1 mole of a compound, water, equals Avogadro number of molecules of that compound, water. And now we'll go back and we have from that ratio, right here, I have it written again. One mole of a compound, so I can put here 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd. 1 mole of a compound equals Avogadro's number. And now, before I pick up my calculator, notice moles of water divided by moles of water, because this is underneath times that. And remember, anything divided by itself equals number 1, meaning it cancels out. This cancels out. I'm left with molecules of water. And now I can happily pick up my calculator, clear it, and now have 8.1 blue double E for 8.1 times 10 to the 4th times 6.02 blue double E 23rd or 23 equal, and my calculator gives me this number. And once again, test number 2 will say, please use proper significant figures for all calculated answers. So now we have to figure out, this has all non-zero numbers are significant to significant figures. Avogadro's number, 3 significant figures. That's what we use for this class. The 1 is an exact number. And my answer should have the same number of significant figures in a multiplication and division as the number with the fewest significant figures, 2. So now you have to round this off to 2 significant figures. How do we do that? Keep the 4, keep the 8. Those are my 2 significant figures. Use 7 to round off. Is that 4 or less, or 5 or greater? And 5 or greater. I drop all this, increase this by 1. And this is my answer using proper significant figures. Again, we used our good buddy, our good friend, unit analysis. But first, when you read a problem, you look at, what am I being asked to find? What am I given? You start with what you're given. You add a ratio. You put down what units you want your answer in, which you figured out here. Then whatever you're trying to get to goes on top of the ratio, follow the top red arrow. Whatever you're trying to get rid of, units, The bottom arrow, where do you get these numbers? Relationship between mole of water and molecules of water. Remember, 1 mole of a compound, this will be given to you, important information. Test number 2 equals Avogadro's number, 6.02 times 10 to the 23rd molecule of that compound. And remember, you have two things equal each other, you have two possible ratios. Let's call this A, this B, and therefore, for every 1 mole of water, I have 6.02 times 10 to the 23rd. Do the math, do the proper significant figures, and that's how you do it. If I look at the clock, we're ahead of schedule, so I think we can call it a day. Don't forget, the lab that you did last week we talked about is due today or late, even I'll take it tomorrow. Make sure you include a selfie from last week's lab with some equipment or something you were doing with last week's lab. And if you have any problems with labs or anything else in this course, remember, in my universe, in my class, there's no such thing as a dumb question. So ask. That's why I'm here, to help you. And with that, I'll remind you tonight, I have my office hour from 6 to 7:15, and tomorrow, Wednesday, I'll have it at the same time. And now I can say, Gehen gesund, goodbye, see you tomorrow, bye.